All right, guys, here I am with the notes. So this is notes 3.6. Let's get into it. There are two ways to write quadratic equations. So we went over last class, and I have the notes here. I'm just kind of referring to them. I'm probably going to write much on them on the PDF right here, so I'm going to make my screen a little bit bigger. Make this bigger, yes. Make this bigger. There we go, a little bigger. Okay, I can zoom out a little bit. All right. So we had two ways to write quadratic equations. So we had the vertex form, which we learned last time. Vertex form. Now we're introducing the standard form. So vertex form is going to be f of x equals, this is a, remember a was the thing that makes it our graph either wide or narrow or open up or down, times x minus h squared plus k, where h comma k is the vertex. That's vertex form. That's why vertex form is great, because you can tell the vertex form immediately. Sorry, my best friend's texting me, so if I look down at my phone, that's why. Standard form. This new form is it's not like vertex form in that you can't tell something immediately, but there are other advantages to it. The standard form is more a little straightforward. F of x equals ax squared plus bx plus c. And that's all it is, where a is always the coefficient in front of the x squared, b is the coefficient in front of the x, and c is the constant value, the constant term. That's all standard form is. And it's really easy to tell. So let's look at a, the first part of the notes here. A, we're given this equation, y equals 4x cubed minus 3x plus 2. Right? And it's not hard to tell what a is. A is just going to be, that's the 4. That's the coefficient from the x squared. Just look at the x squared. Bam. Whatever's in front of it, that's the a. Negative 3 is b here. Right? It's negative 3. It's not just 3. It's negative 3. C value here is the 2. Right? So not hard to read quadratics in standard form. B here, y equals negative 3x squared plus 7. So a here, what does a equal? A is negative 3. Again, it's the coefficient in front of the x squared. It includes the negative if there is one. The b is the coefficient in front of x, but I don't see an x here. I don't see an x to the first power. I see x squared, but I don't see x to the first power. Which means b is 0. And then c here is just that constant term 7. Right? Again, once you practice enough, it gets actually really easy. C here, y equals 9x minus x squared. First thing I think about on a problem like C is that it's not in standard form. It's like kind of backwards. The x squared should be first. This should be y equals negative x squared plus 9x. That's what it should be. And if you have it in that form, it makes it easier to tell what it was A and B. So A here is negative 1. You see it's negative x squared, so A is negative 1. B here is just positive 9. And C here is 0. You don't see a 0 here, but you could always put a 0 if you want to. Right? That's the same thing. It doesn't change at all. And D, the last one. The last one here is y equals 4x squared minus 3x. And again, really easy to tell. The 4 is the A. A here equals 4. B is negative 3. Right? So once you do it enough, it's really easy to tell. Okay, now the main thing about the notes here, I'm kind of sort of skip. I might do half the notes or something like that, but I'm going to go over just the main thing to get from notes 3.6. The main thing to get from notes 3.6 is to go from standard form to vertex form. How do we go from standard form to vertex form? So again, standard form looks like this. Standard form one more time. I'll write it as f of x. some function f is equal to ax squared plus bx plus c. That's standard form. If I want to go to vertex form, I need to know h, I need to know k. A is the same either way. A is the same either way. Again, this is vertex form. I'm going to write it one more time. It's a little overkill. I wrote it already. I'll write it again. Right? To get vertex form, I need to know h and k. So how do I find h and k when I have it in standard form? So this is important. H is equal to negative b over 2a. That's important. That's something to keep away in your notes. Make sure you write that down in your notes. This is important. Negative b over 2a. That's how you find h. And then k, the vertical shift, is equal to f of h. Meaning, once you find your h value, you plug it back into your function f, and that's what will give you k. So let's practice. So the first one we have here, a here, they say, this is kind of that second row. If you want to follow along with the notes, this would be right. Do this. We're looking at this one here. Now this one's graphed for us, and if you can graph it for us, that's great. I'm gonna kind of imagine if it wasn't graphed for us. If it wasn't graphed for us, the equation here is y equals 3x squared plus 12x plus 7. Right? So there it is. That's the standard form. It's a standard form. So immediately I want to find h. If I want to go to vertex form, I'm going to find h, and that's going to be negative b over 2a. So h is equal to negative b over 2a. Here the b value is 12, so just take negative of that, negative 12 over 2 times a. A is 3 here, right? It's 3x squared, so a is 3. Negative b over 2 times 3 is negative 12 over 2 times 3 should be negative 12 over 6, which is just negative 2. That is what h is. H is negative 2. So I can go ahead and write that. Here, I'll write it. H is negative 2. Then to find k, I just need to plug negative 2 back into my function. So f of negative 2. Or just plug in wherever you had an x. So wherever you had an x, now I just plug in a negative 2 and then evaluate that. A negative 2 squared, negative 2 times negative 2 is 4. 4 times 3 is 12. 12 times negative 2 is negative 24. 12 minus 24 is negative 12. Negative 12 plus 7 is negative 5. So k is negative 5. So once you know h, once you know k, and you still know a, there's a right there, it's 3, you can write in vertex form. So vertex form, I like to write it as an f, like in function notation. F of x is equal to the a value, 3, times x minus h. Here, h is negative 2, so x plus 2 squared. Now k, so minus 5. Right, so this is the same thing as that. This is just vertex form. Vertex form. This is standard form. They're the same thing. Now, the subtle differences between the two is that in vertex form, I can tell the vertex immediately. I know the vertex here is at negative 2, negative 5 immediately. With standard form, I can't tell that immediately. One thing is that the c value here, this is the y-intercept. So that's something to know. I know y-intercept is positive 7. But you can't tell that immediately from standard form. So there are some advantages here. So the vertex, again, vertex in this case is at negative 2, negative 5, which if you graph it, you can tell that pretty easily. The axis of symmetry is always x equals h. So x equals negative 2. Just to think about that a little bit more, let's look at Desmos really quick. Desmos really quick. That's the bell schedule. I got to make sure I know when I have my next class. So again, here's Desmos. Let me move my head. Right, we started off with this equation, y equals 3x squared. There becomes a parabola. 3x squared plus 12x, and then plus 7. That's what we started off with. In vertex form, we wrote like this, y equals still 3. And we had this x minus 2, x plus 2, sorry, x plus 2. And then we had that minus 5. And notice how, again, it's the blue one's the exact same thing where the red one was. So we know these are the same graph, just different equations, different ways to see the same thing. And of course, the vertex is at -2, -5. The axis of symmetry is x equals -2, right? If I make that dotted line, I'll make it a dashed line actually. Right, we can see it goes right down the middle here, right down the middle of that quadratic. So that's the axis of symmetry. If I was looking at, and that's if you graph it. Now, if you have it graphed already, let me go back to there. I'm going to make this. I'm zoom in a little bit here. Let me clear my drawings, and I'm going to mouse zoom, 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 zoom. Oh, wrong button. Let me just zoom in the other way. I know how to zoom in. Make this. Let's do it 150%. Click. Moves over. Okay, so now looking at B, I mean a little bit bigger. B, if I want to tell the vertex, like if it's already graphed, it's not hard to tell the vertex. It's pretty obvious. It's right there. That's the vertex, right there. So the vertex is at the x value is +2. The y value is +1. So 2, 1. That's the vertex. The a value here, if you just look at this in standard form, a value is 2. B value is -8. If you were to, right, if just to prove it, here again, y equals 2x squared minus 8x plus 9. So again, you can't see that. There it is. To find the h value, a -b over 2a. In this case, b is -8, so -8 is +8 over 2a. 2 times 2, a is 2 here. 8 over 4 is 2. 8 over 4 is 2. And again, that's what the h is. You can see the vertex. The x component of the vertex is 2. I plug 2 back into this equation just to double check everything. 2 squared is 4. 4 times 2 is 8. 8 times 2 is 16. 8 minus 16 is -8. -8 plus 9 is 1. So your vertex is at 2, 1, which is what we get from we saw that from the graph. Like if it's already graphed for you, you don't really have to do the -b over 2a part. You can just look at a graph. But both ways reflect each other. So two different ways to do the same thing. All right, let's see. And then C is the same thing. You can see the vertex right away. Vertex is at 2, -1, right there. So that's pretty easy to solve that. So let's press on. What's in the notes here? Let me zoom out a little bit. So what they're saying here in this little box is essentially what I already said about the -b over 2a. If you wanted to write, this out, you can find the vertex of any parabola written in standard form in 2 steps. So find the x value or find the h, right? That is the x value if you want to think of that as h. By using the formula negative b over 2a. That's how you'd write like that. And then you plug in, to find the y value, you substitute the x value, you plug in the h value into the original equation. So that's all they're saying there. Let's see if we can go down. So I might do like one more example here, because time. Where are we at? We're at 15 minutes. I don't want to go much longer. I'm gonna do probably one that I wouldn't do in class, like number 3. So solving number 3. Again, once you get the hang of it, it's very easy. F of x equals 2x squared plus 4x minus 5. Right? So again, a here is 2, b here is 4, so it's negative b over 2a. It does not hurt to keep writing that over and over. Negative b over 2a. So it's going to be negative 4 over 2 times 2. A here is 2. Negative 4 over 4 is negative 1. So the h value here is negative 1. Plug that back into this function. So f of negative 1 is 2 times negative 1 squared plus 4 times negative 1 minus 5. And then evaluate. Negative 1 squared is positive 1. Negative 1 times negative 1 is positive 1. Positive 1 times 2 is 2. Negative 1 times 4 is minus 4. And you have the minus 5 there. 2 minus 4 is negative 2. Negative 2 minus 5 is negative 7. The k value is negative 7. So then just put it together in vertex form. So it'd be f of x equals the a value times x plus 1, right? It's x minus h. Here h is negative 1, so x plus 1 squared minus 7. So I'm just going to graph that. It's opening up. The vertex is in the negative area, so I'm going to go this. So I'm sketch it like this. So let's see. 1, 2, 3, 4, 5, 6, 7. There you go. That's the point. Negative 1 comma negative 7. There's your vertex. This is opening up because of the 2. When you're graphing this, you again, I think I mentioned this in hopefully your class. This idea of when a is 1, like in the parent function, you have this relationship of going over 1, up 1, over 2, up 4, over 3, up 9. That's just taking 1, 2, and 3 and squaring them, right? Now that a is 2, right, this is if a equals 1. If a equals 2, I'm going to double all this. So 2, 8, 18. So from the vertex, I'm going to go over 1, up 2 in both directions. From the vertex, I'm going to go over 2, up 4. No, sorry, up 8. Over 2, up 8. Talking about there. And those 5 points are enough to graph this. So there's your graph. You have points at, this is at 0, negative 5. Should be at 1, 1. This would be at negative 1, 2, negative 3, 1. If you plug all these values in, they would work if you're graphing it. So that's how you graph it. It's easier to graph from vertex form. I will say that. Very much easier to graph from vertex form. And then the rest of the examples are basically the same. I'll do one more, looking at my time. Yeah, okay, I'll do one more. Do number 5. Number 5. So again, we're given some equation here. F of x equals 1/4 x squared plus 2x plus 1. I know right away it's going to be a wider graph because the a value is 1/4. But let's find the vertex. So again, negative b over 2a. Negative b here is 2, so it's going to be negative 2 over 2a. A is 1/4. 2 times 1/4, if you have a fourth of a pizza and you have 2/4 of a pizza, that's 1/2 of a pizza. -2 over 1/2. When you divide by a half, it's the same thing as multiplying by 2. So -2 divided by a half is -4. So your h value is -4. Plug this into your equation. So f of -4 equals 1/4 of -4 squared plus 2 times -4 plus 1. -4 squared, -4 times -4 is positive 16. 1/4 of 16 is 4. 2 times -4 is -8. Plus 1. 4 plus 1 is 5. 5 minus 8 is -3. So the k value here is -3. So then to put it in a actual vertex form, I'll write it here, f of x equals same a value, so 1/4 times x minus h, so here h is -4, so it'll be +4 squared minus 3. So there's that same thing in vertex form. We can tell the vertex right away. Let's graph it. Graph it right here. So the vertex is at -4, -3, so it's going to be that's in the third quadrant. So I'm going to kind of skew my graph over that a little bit. So it's a little bit third quadrant heavy. So -4, -3. So 1, 2, 3, 4. 1, 2, 3. This. It's going to be very wide and it's going to open up. Again, I'm going to write this. You see me write this a lot. This 149 business. And you could keep going. You could do 1, 2, 3. You can go 4, 4, 16. You could do 5, 25. Something like that. So because our a value here is 1/4, it's going to make our graph much wider. So I'm going to multiply all these values here by 1/4. So 1 times 1/4 is 1/4. 4 times 1/4 is 1. 9 times 1/4 is 9/4. 16 times 1/4 is going to be 4. Really, that's enough. I don't need no more than that. So here's my vertex. Right, that's a -4, comma -3. Opening up. So from the vertex, I'm going to go over. I can go over 1 up a 4. That's kind of hard to graph, but I could go over 2 up 1. Over 2 up 1. Both directions. 1, 2, 1. Right? I can go over 3 up 9/4, which is 2.25. It's a little bit hard to graph that, so I'm going to actually skip that. I'm going to go over 4 up 4. And again, where are these numbers coming from? Well, 4 squared is 16, and then 1/4 of 16 is 4. Our a value is 1/4. So from the vertex, I'm going to go over 4. 1, 2, 3, 4. Then go up 4. 1, 2, 3, 4. 1, 2, 3, 4. 4. So there's our graph. Usually 5 points all it needs. Notice it's much wider. If you compare it to like that one, where A was 2, a little more narrow, a little more wide. So last thing to think about, domain. Domain here is almost always all real numbers, like that. That's the double R thing, R 2 lines, all real numbers. Or you could write all real numbers, something like that. I know what you mean. The range here is going to be, the lowest point is at -3, right? That's the low point, -3. So you can say -3 to infinity, and you're including -3, but you're not including infinity because you can't include infinity. Or you could write y is greater than or equal to -3, like that. Either way, or you could write it -3 is less than or equal to y is less than positive infinity, right? Those are all the same way to write the range. Axis symmetry is at x equals -4, right down the line right there. And then does it have a minimum value? Yeah, you're looking at it. It's the vertex. It opens up, has a minimum value. Easy peasy. All right, there's notes. I didn't do all the notes, but I'll do the rest of the notes in class, but that should help you on most of it. Main takeaway, where is it? Right here, negative b over 2a, this thing. This is the main takeaway from today. Make sure you have that written down somewhere. That's the main takeaway today. All right, I'll see you guys in class.